In section 4 of chapter 7, we're going to be addressing a problem that we've already kind of previously addressed, but we're going to make it a little more complex. We are going to be rationalizing denominators of fractions. Here's an example of a problem that you've done before, mixed with the problem that we're going to be doing today. Problem number 1, we have 1 over the square root of 3. We don't like radicals in our denominators, so we need a way to get rid of that radical in the denominator. What we do is we multiply the top and bottom by the square root of 3. Because if I can turn that square root of 3 into the square root of 9, I can take the square root of 9. That is equal to 3. That would be our answer. Relatively straightforward, relatively nice. Those problems aren't too bad because the denominator is a monomial. One thing, it's just like a root 3 or a 2 root 5. There's no plus or minus anything. As soon as we move to problems like number 2, where now we have a binomial, things get a little more tricky. Because if you try and take the same tactic, multiply top and bottom by the square root of 3, spoiler alert, this is not going to work. Because what you'll get is a square root of 3 on top, because 1 times root 3 is just root 3. And then when you distribute that root 3 to both terms, you would get a root 3 plus root 9, which will simplify into root 3 over root 3 plus 3. While we did get rid of the root that was on the second term of the binomial, we now have a root on the first term. That doesn't work. You can't just multiply by the root that you want to get rid of. This technique doesn't work. All right, so we got to do something else instead. Here's the second thing that students typically try next, which is to say, okay, well, in the first problem, we multiplied by the denominator. So let's just try multiplying by the entire denominator. 1 plus the square root of 3 over 1 plus the square root of 3. Spoiler alert again, this also won't work. Because when I multiply that out, I will get 1 plus the square root of 3 on top, and then first term times first term, 1 times 1 is 1. First term times second term, 1 times root 3 is root 3. Second term times first term is another root 3. And then lastly, second term times second term is going to be root 9. When you simplify that, you're going to get 1 plus the square root of 3 over 1 plus 2 root 3 plus 3, which simplifies into 1 plus the square root of 3 over 4 plus 2 root 3. There's still a radical in the denominator. This technique doesn't work. You need to be more careful and more specialized. Here's the first thing that I want to note. The reason there's a radical in this technique, the reason this root 3 exists, is because it came from here, which came from here. It came from the middle two parts of when we multiplied the binomials together. So we need a way to get rid of these middle two parts. Luckily, I've already shown you how to do that in a previous lesson earlier in the year. If you recall back to when we multiply by something called a conjugate, that is to say the terms are the same except one is a plus and the other one is a minus. When you multiply those two binomials together, x times x is x squared. X times negative 3 is negative 3x. 3 times x is positive 3x. And positive 3 times negative 3 is negative 9. Notice that the middle two terms, which is what the issue was in the previous problem, they eliminate, just leaving you with x squared minus 9. It leaves you with the first term if you squared it minus the second term if you squared it. If you're going through that process of having the individual terms squared, that gets rid of the radicals. So now with problem 2, now I have a binomial times a binomial with radicals in it. When I multiply that out, x times x is x squared. X times negative root 3 is negative x root 3. Root 3 times x is going to be positive x root 3. And then positive root 3 times negative root 3 is negative root 9. The middle terms eliminate, and you're just left with x squared minus 3 is our answer. Additionally, if you really hate writing out this middle step, again, there's a way to skip this. If you recognize you're multiplying conjugates together, This is just the first term squared minus the second term squared. So for problems like number 3, I could write out this middle step again if I wanted, or just realize it's the first term squared, 5 squared is 25, minus the second term squared. 2 squared is 4, root x squared is x. There's my answer. So here are 3 examples that I want to briefly run through. Once you understand how to rationalize denominators involving monomials and binomials, it's something that you can largely just do in your head. Problem number 1, if you have a monomial in the denominator, you just multiply by the monomial, as long as it's a square root. That gives you 5 root 2 over 2. That's our final answer. As soon as we get to binomials, you're going to multiply the top and bottom by its conjugate. That is to say 6 plus x root 2 over 6 plus x root 2. And because I know how to multiply conjugates together in my head, it's just the first term squared minus the second term squared. I don't have to write a whole lot of work. And then lastly, problem number 3, I just felt like throwing something in there that's a little bit more challenging. I'm going to multiply top and bottom by 2 plus 5 root x over 2 plus 5 root x. When you multiply out the numerator, 2 times 2 is 4. 2 times 5 root x is 5 root x. 5 root x times 2 is, oh, that's not 5 root x, that's 10 root x. That's going to give me another 10 root x. And then 5 root x times 5 root x is going to be 25x. And then the denominator is going to be the easier part because it's just the first term squared minus the second term squared. These two are like terms, which is why my final answer is going to be 4 plus 20 root x plus 25x over 4 minus 25x. And that is my final solution.